Hello, today we're going to go over how to calibrate your OAKTON CTS 50P specific conductivity sensor. In order to successfully calibrate your meter, you're going to need a pen or a pencil, your calibration log, 1413 microsiemens solution, distilled or deionized water, and of course your meter. So we'll start the process by turning the meter on using the power button. You should see the meter start to kick on. Once the meter is warming up here, the first step is we're going to go ahead and record the serial number of our meter on our calibration log. Your serial number is generally written on the side or on the back of your meter if you're using a Milwaukee Riverkeeper meter. Once we recorded our serial number on the top of our calibration log, the next step is we want to put a big X through the columns that read the 10,000 microsiemens conductivity standard. The reason for that is the OAKTON 50P specific conductivity meter only requires 1413 solution to calibrate, so we don't need to use any of these columns. Once we've done that, we're going to go ahead and record the date, the time, and our name in the first three columns of the calibration log. Okay, next we'll go ahead and remove the cap of the meter. And the first thing we're going to do is we're going to take our 1413 calibration solution and we're going to rinse the probe of the meter with that solution. And we are going to triple rinse our cap with our 1413 standard solution. Rinse it out 3 times, dump it out a third, and then we're going to go ahead and fill it up a fourth. And if you notice on your cap, there's a small line that shows max fill line. You'll want to fill that up to about there. That'll leave you enough solution to get the probe totally submerged, but not spill a bunch over the top of the cap. So we'll go ahead and fill that up to the line. Next, we're going to go ahead and place our meter into the cap with the 1413 solution. And you'll notice we're going to wait for the reading on the meter to stabilize. And the way we can tell that the meter stabilized is there'll be a small check mark that'll show up at the top of the screen when it has stabilized. Continuing to read. Sometimes it's a little slow, you just have to be patient with it. You can see the small check mark. That means that the reading has stabilized, and we can go ahead and record that stabilized reading in the initial reading column of the 1413 conductivity standard column on your log. Next, we're going to record the measured temperature, which is at the very bottom of your screen. It's indicating it is 21.2 degrees Celsius. So we're going to go ahead and record that in the measured temp. Once we recorded that, we can go ahead and press the cal escape button 2 times to enter calibration mode. You'll notice that the meter is cycling through and it's working to identify what calibration solution we're using: 1413, 12.8, and 84. It'll continue to do so until it recognizes the 1413 solution. Once you see the 1413 flashing at the bottom and the check mark, it'll indicate that the meter has recognized the calibration solution. Check mark and the flashing 1413, we can hit the enter button and you'll see a cal and a check mark briefly appear on the screen. From there, you're going to wait for the small check mark at the top of the screen to reappear, and that will be your adjusted calibrated reading. So in this case, we see our check mark. We have a reading of 1414. So we're going to go ahead and record that in the adjusted reading column under the 1413 conductivity standard box. From there, we can go ahead, remove the probe out of the calibration solution. We're going to go ahead and rinse the probe with deionized water. We're going to dump the cap. And we're going to triple rinse our cap with DI water. Fill up the 4th time to that max fill line. We're going to go ahead and place our meter back into the deionized water. From there, the meter is going to cycle through, and you're going to wait for that small check mark at the top of the screen again to indicate that it is a stabilized reading. And we can go ahead and record that now that we've seen our check mark at 1.1. We're also going to record the temperature of the deionized water as well under the deionized or distilled water column on your calibration log. So the ways you can determine that the calibration was successful is you want to ensure that your 1413 reading, your adjusted reading under the 1413 calibration, was between 1366 and 1460 microsiemens. In this case, we had an adjusted reading of 1414, so that's good. You also want to ensure that your reading for your deionized or distilled water is under 10 microsiemens. In this case, we had an indicator of 1.1, so that's a successful calibration. A brief note, throughout the calibration process, it's important that your screen is reading, ensure that the meter is reading in microsiemens, which is a small US/cm, rather than millisiemens, which is an ms/cm. So it's important that you're verifying that throughout this process, it's reading in microsiemens, which in this case it is. Additionally, with the calibration meter, once you've completed, the CTS 50 can be shut off until you use it in the field, and you can turn it on and off between sites. So you can just hold the power button until it turns off. We'll shake any excess water off of our probe. We'll return the meter to the cap, and the meter is now ready to be used in the field.